Hey, good afternoon, everyone. I hope you're enjoying your time here at the AWS Public Sector Summit. My name is George Mao. I'm a specialist solutions architect at AWS. I've been with the company for about 3 years, and it's my job to help our customers build solutions on the AWS platform, all without no servers. So, Wayne?
Yeah, and I'm Wayne Seeger. I am currently a solution architect at Dynatrace. Been there for a number of years, and I'm currently working with our customers, basically taking them on the journey of moving their software from the monolithic type of architectures that they have and are very prevalent in the enterprise, and getting them into a cloud-based and eventually to a serverless type of architecture.
Cool. Thanks, Wayne. So why don't we get started? So what we're going to do here today is we're going to talk about the evolution of serverless computing, and then we're going to talk about how serverless computing can help you move from a monolith architecture towards a microservice-based architecture. And then Wayne's going to give you an overview of the Dynatrace platform and show you how Dynatrace can help you along that path. So the first question we have to answer is, what is serverless? So over the last decade, right, computing has been evolving into higher and higher levels of abstraction. Right? We used to have to worry about, in our data centers, we had to worry about capacity and servers and infrastructure. And as we moved into the cloud, we're able to deploy that capacity rapidly and get that capacity almost instantly. Now, as we move into serverless, as we evolve into the serverless world, you're able to run your applications without ever thinking about servers. Right? Your developers can focus on building that business logic and then deploying that out to your cloud providers like AWS. So raise your hand if you've ever had to manage a server or a fleet of servers before. Yeah, so that's like over half of the room. So basically, you know that owning servers means that you own the life cycle of your instances. Right? You own the operating system, you own the patching, you own all the network details, infrastructure, everything behind the scenes to keep your systems operational. So you also own the provisioning and utilization. So that means that you have to understand how many instances you want to run, the types of instances you want to run, and at the end of the day, the question you're trying to answer is, could you have run less to save on cost? Right? So when you're running in AWS, we have a service called auto-scaling groups that can help you with that and dynamically scale up and down. So as we talk about scaling, servers means that you have to understand and put logic in place that helps you decide where to place your work. Right? How busy it is you want to keep your instances, and how much workload you want to keep running actively across your server fleet. And then as with any production application, you have to build in high availability, durability, and fault tolerance from ground up from day one. Anything that goes into production needs to be as highly available as possible. Right? So if we rewind back to the 1990s, right, we always had to provision our data centers all the way to the maximum demand that we think we needed. And that's because it could take weeks, months, maybe even multiple months to get that capacity. Right? Now, as we moved into the cloud, we're able to get that capacity really quickly. We still need to manage that capacity. Right? You don't have to manage the physical infrastructure, but you still have to manage all the things that we spoke about earlier in the previous slide. So now, as we move into serverless, your developers can simply focus on your business logic that matters to your business. And what this means is that it's really driving down the time to market for all of your applications. Right? When I was developing applications and deploying them to physical data centers, I was thinking about development cycles that lasted months and sometimes years. Right? And now with serverless, you can deploy your applications, build them in weeks, and sometimes even just days. So one thing to keep in mind, as we're moving into the serverless world, it's also changing the way we're building our applications. Right? So we're no longer building these huge monolith applications. Right? So we're building smaller applications that are microservice-based that can be deployed across multiple different instances on the back end. Right? So that's why AWS launched a service called AWS Lambda. And Lambda is a compute service that helps you run your code without ever thinking about your servers. So what you do is you write your application code, provide it to AWS, and we execute it for you in response to events. Right? So what that means is we move the unit of scale away from a per instance or per host level to a per request level. So what that means is every Lambda function is acting as a microservice and servicing a specific business need, right? You no longer have any idle. So with Lambda, the best part about Lambda is that you only pay when your Lambda functions are up and executing. Right? You're not paying for storage. You don't pay when your Lambda functions aren't doing anything. You're paying specifically to deliver business value. Right? So has anybody written a Lambda function before? Probably 20% of the room. How about who owns an Alexa device? Or Dot, Echo Dot, Alexa, Echo Show. So like 70% of the room. Right? So those skills behind the scenes, when you say, Alexa, what is the weather today? Most of those skills are actually powered by AWS Lambda functions. You can go in there, spin up your developer toolkit, and then just create your own skills. Right? You can say, Alexa, tell me about my Amazon environment, and it can just spit out whatever it is you want it to spit out. So let's talk about how Lambda works. Right? It's actually a very simple programming model. It's just based off of an idea that you can call a Lambda function, or you can have it automatically react to an event. Right? And that event could be a change in data state. So for example, you might have a record that gets inserted into DynamoDB, and you want to perform some kind of action on that. Right? But you don't want to have a huge fleet of EC2 instances that are polling your DynamoDB table for changes. Right? You can have Lambda functions spin up, react to that insert, and then do something with that data, massage the payload, and then put it somewhere else. Right? Or it could be a request made to an endpoint. So you could have an API gateway endpoint stood up. When you have a message that pushes into your API gateway, you can have it invoke a Lambda function, perform some kind of business logic on the API call that one of your customers or your clients has made. And the last event source is something called a change in a resource state. So a change in a resource state, for example, is like when a user or a customer uploads an object into S3, right? And you want to do something, and you want to react to that upload. So traditional applications, like FTP-based applications, you drop a lot of files on basically folders, and you have these polling mechanisms that detect files, and you want to react to that. Instead of doing that, you can have changes in resource state that invoke Lambda functions, spin up your microservice, perform the necessary actions on those files, and shut down and go away. So Lambda functions can be written in your favorite programming language, in any one of these 5 languages. And within a Lambda function, you can do anything you want. You can invoke an AWS SDK. You can invoke a third-party API. You can talk to something in your VPCs. You can query your RDS databases. Pretty much anything you can do today with any one of these programming languages, you can do within Lambda. Right? So now what's most important is, as you're building your Lambda functions, because they only spin up and execute when needed, you can build really scalable, fault-tolerant, but also cost-effective applications. Right? So now, back to splitting up your monolith. Right? So the goal in a microservice architecture is you want to break up your monolith application into microservice-based components. And each component should essentially represent some kind of service that you're trying to provide, you're trying to sell, you're trying to host. Right? And each of these components should have a way of communicating with each other. Right? So your microservices shouldn't be siloed microservices that only perform their own work and have no way of moving towards an end goal. So your microservices typically today communicate with each other through lightweight payload formats such as REST, JSON, sometimes XML. We still have communication formats using XML. So communication, remember, is important between microservices. Don't build them so that they're siloed away from each other. Right? So AWS has multiple different services available in the serverless platform that can help you create your microservice architecture in your own platform. And the Lambda service kind of is the compute service that acts as the business logic that can connect all of your applications together. Right? It acts as the glue between all of your applications. All of your programming languages can be put into Lambda, deployed, and then executed as needed in response to business demand and business needs. Right? So let's take a look at some examples here. The first example is you might be building you might be using Amazon API Gateway to easily create REST endpoints and APIs. And that's a very common thing that software vendors are doing today, right? So within these APIs, as you push messages through your APIs, you typically need to perform some business logic on these messages as they come through before you can push these messages to your downstream service. So in this example, we have a message coming in through API gateway. It gets pushed into SQS. But what we're going to do is use Lambda functions to react to those messages, verify them, maybe remove sensitive information, check the validity of the message, and then push it to your downstream service, right? So let's move on to another example. In the second example, it's all about data persistence, right? Today, applications typically need to persist data to one or more data sources, right? So as messages flow through the same API, you might have a requirement in your applications that says, I want to persist my data to a transactional database, like DynamoDB. At the same time, I want to push it also to a real-time streaming service like Kinesis. But you also might need to persist data to an analytical database, such as Amazon Redshift, right? So with a monolith application, it's difficult to do that because you have all of these libraries, all these requirements, all this application code that needs to go into one huge package. So instead of doing that, you can use Lambda functions and microservice-based architecture to each do its own task, right? Each would perform its individual tasks, execute that task, spin up and shut down and go away, and have no cost when there's no business work to be done. And so let's take a look at our last example here. So in this example, this is about workflow management, right? So a lot of our applications today allow users to upload files, right? Objects. And for example, you may be building a social media application that allows users to upload images and photos. The first thing you need to do is be able to store those images and photos, and you might be using S3 to do that, or some other data store. But before you store those photos, you have to create different thumbnails, different resolutions that can be deployed to all sorts of different devices. Right? You might be creating 10, 15 different resolutions of the same image. You have to create snippets and screenshots of all your videos that are coming in. Right? Each of these tasks requires different libraries, different dependencies, and all of these require different resources. And it takes execution of these tasks. For example, editing and processing and compressing a video will take much longer than simply resizing a photo, right? So if you were to create a huge monolith application that bundles all of this workload and dependencies together, number one, the application will probably be a very massive deployment binary, right? Number two, as your user base scales, how do you scale that monolith application? You create copies of it, you deploy it into multiple servers, and then shard it up across a load balancer, right? So in microservice-based architecture, you can have a Lambda function that's responsible for each one of these tasks, right? And as your user base grows, maybe the image upload feature is more popular than the video upload feature. And you can just scale that single service by itself, right? Or you find a bug in your video processing service, and you need to replace the library that's processing your videos, right? So you can go in there and easily replace that library without affecting any of your other applications that are up and running. Scaling becomes easy, it's cost effective, and you don't have to worry about where your traffic and your user base growth is going to be when you're actually building your applications. So one last thing to keep in mind, when you're building applications, microservices, especially ones that are running on Lambda, is that these Lambda functions are basically ephemeral, right? So what that means is when you're spinning up your Lambda functions, when AWS executes a Lambda function, all the work that's being done, it only lives during the execution of that Lambda function, right? So if you have any data persistence that needs to live beyond the Lambda function, you should persist it to a long-term data store, DynamoDB, RDS, or any data store that you're using. Right? As your Lambda functions shut down, everything will go away, right? So that means you're not paying for idle, but you also have to take your data and make sure it's persisted to a store that's external to the Lambda service. Right? So that's a pretty good overview of microservices with Lambda. Now Wayne is going to give you an overview of the Dynatrace platform.
All right, thanks, George. And thanks again for the great overview on the serverless side. So what we're going to talk about now is how you actually can get there. So has anybody, let's just do a raise of hands here. How many people have actually heard of Dynatrace or maybe have using it? Okay, so good percentage of the room. So there's a couple facts up here, and I'm not going to read through all of them, but Dynatrace is been around for a while in the monitoring space, focusing now a lot on the AI-based monitoring front. And as you can see, we've been doing this a while, have a lot of customers in the space, and we are also a Amazon partner. And we also run our own SaaS-based workloads on AWS as well. So, but the very fact that we've actually been around for a little while, we've had a product that was a monolithic type of application, and it worked very well for monitoring monolithic applications, but going to the type of environments with microservices and other things in the cloud was something that it was not optimized for. And so that's where we actually kind of reinvented ourselves and basically created our own little digital transformation where we created our own product and broke it apart, almost like broke apart our own monolith. And that's a little bit about what we're going to talk about today, and how that process that we had to go through, how we actually took a lot of those challenges and built them into features to help customers like yourselves break apart your different application components. So as you can see, what this has actually done is allowed us to turn ourselves into a company that can change and commit code more frequently, push out releases more frequently, which are things that I think everybody is really trying to achieve. Ultimately, the faster you can write a feature or fix a bug and get it out to a customer, that's the more beneficial way to do it. So some of the challenges, we'll start off with really the three challenges that go along with the kind of the migration path that customers run into when they're trying to go and move into from the monolith and eventually get to microservices and serverless. Is the first question really is, where exactly do you start? And that tends to really be the big question, is what are the dependencies? So if you just want to move one thing, you want to pick apart a couple components or move something, which area do you start? And by doing so, what are you going to impact? What downstream or upstream impact are you going to have? And that is very challenging at times to understand just in general how things are related in a large environment. So after you get to that next phase, though, and maybe you've broken some things apart, it comes really validation. So now you have to actually validate that the application or the things that you just rebuilt or re-architected and broken out into the different services are working as you designed them to. Ultimately, is the customer experience the same or better than what it was previously? And is it scaling the way that you actually anticipated it to? And then finally, as you get to the next phase onto the journey, which is now starting to utilize some of those services that George was mentioning before, API gateways, DynamoDB, Lambda, is that working in the function you designed it to? And how exactly do you go about automating that? And how do you go about visualizing that? Because now, again, you're kind of giving away pieces of the architecture that you're used to owning, like databases and stuff. And now you're going to be kind of giving that away. So how do you visualize that in your whole topology, and how do you continue to monitor that in one dynamic view? And so this is actually a view from Dynatrace that actually breaks down and why we say full stack and what what we call our one agent technology actually does. So if you actually take a look, and I'll highlight some of this for you, is we try to do this basically at the full layer, all the way starting up at the application, going through the different services that the application ultimately talks to, and then down into the infrastructure layer of the processes, the containers, into the actual physical infrastructure if you're using EC2s or something like that, and then finally down into the data center level, or in many cases, the AWS availability zone. And so this is just some snippets here of the data that gets present, or what you would expect along the route there, which up at the application top is being able to see how well, when a customer goes to, let's say, a web application or a mobile application, does that page actually load? Is it actually performing the way you anticipate? And then when it talks to all the back-end services that actually make up that page, maybe it's a single-page application that's just making XHR calls, how are those services reacting in the back-end? And then finally, when you get down to the infrastructure level, is how is that scaling out? In this case here, you're running multiple processes, multiple containers. How many do you need to run? And so this is just type of view that we felt was very important to provide to customers and that we required when we were going through our little journey is to have that full view from the actual end user of the application through all the different layers that the transaction that he or she will commit goes through, and ultimately down into the data center level. So how is it that we applied some of the Dynatrace principles to these different challenges? And so the first area, when we talk about what it is and getting your dependencies together, and you'll see a picture of this in the next slide, is our Dynatrace Smartscape. And our Smartscape is actually designed to give you a virtual blueprint at all the different levels, the applications, the services, the containers and processes and infrastructure, all in one view, and show you how things are interconnected and make it searchable and filterable. So you can actually see when one component there is, when you select one component, what other things actually touch it. Now the second piece is the validation point of how do you determine things are working the way you anticipate. And one of the things that we focused on was actually building an AI component onto this to actually look for problems or look for degradations that happen. So if you think about if you're baselining your performance and your health of a service or of your application stack before you go to deploy or re-architect it, what does it look like after? And the AI actually can look for differences. And finally, what we really focused on was now that you're going to start, and you may say that your Oracle database that you're running on premise, maybe you're going to use RDS in the cloud. And how can you visualize that in the same topology model? Because now you don't have the infrastructure anymore. And that was another focus of ours, was to make sure that we're pulling in and actually taking those cloud services and putting them in context with your on-premise running services. So this is a view here of our Smartscape, kind of a snapshot. And what this allows you to do is, quote unquote, t-shirt size, small, medium, large, extra large, what your migration plan or what your strategy would be around a single application here. So if we look at this example here, we just kind of have a Tomcat service, but you can see that there's actually many different endpoints. It's dropping things into queues. It's getting requests in web request-wise, and it's scaled out across 4 different instances across a couple hosts. And we can actually even look at these different views here and see which machines are dependent upon each other. So kind of like 2 interesting examples, real world, of where we've run into this becoming a necessity is we actually had an old Atlassian kind of Jira instance that we had since our company really was founded. And so it's just we've had it there and it's kind of just grown ever since. So we wanted to just lift it and shift it and move it into the cloud so we didn't have to deal with just running the server hardware anymore. And so one of the back-end databases for it, though, and because it's a very simple component, it kind of just has a front-end kind of Java tier, and then there's a back-end database to it. And so we were just going to kind of move it out to an RDS instance and make sure that the main application server of Jira actually could just talk to it. And that was really going to be it. Well, when we actually put on our one agent onto the machine that was hosting the database, and we looked at the database services and a couple other things in the environment, what we saw was there was actually a ton of services out there that were connecting directly to our database, basically the Jira database, because that was the source of where you can get information. So somebody just decided I needed to get information on tickets that maybe the Jira UI or something wasn't providing me, or I needed to get data for some other application. And so I wrote something, and now I'm talking to that database. Well, now if I go and pick that database up, move it out to the cloud, and I didn't even know to tell the owner of that other application about that, well, that would not work come Monday morning after the migration. So this was actually something here that it sounded very simple on paper, but once we actually got into the details and just started looking at just some of the real-time data that was actually flowing there, it became a lot more difficult. Another example was from one of my customers, a large bank, and all they wanted to do was upgrade a database instance. They were running an older version of DB2. They just wanted to upgrade it to another version. So they weren't even actually going through and migrating anything, just as simple as an upgrade. But of course, with an upgrade, you're going to have downtime and potential data loss if things get transacted. So you want to not allow for transactions. So you pick a time that makes sense. But the problem was, initially, without looking at this type of data here and seeing the dependencies mapped for them, they did not know which applications needed to basically put a blackout splash page there, so somebody couldn't try to commit like a wire transfer or commit a trade or something that would require interaction with that database that ultimately could get lost because it was going through maintenance and an upgrade. So being able to just see how dependencies interact is pretty important, and that's where our Smartscape comes in. So the next phase is now talking to how exactly do you want to break up, if you're back to like your monolith, how are you going to break that apart into the varying different components? Like where do you start? Which areas, which services inside do you need to look at? So if you think about like a simple transaction flow of like your typical monolith, you'd have a web server in front like we have here. And then you would have kind of maybe the monolith itself. So think of it like maybe like WebLogic, WebSphere, JBoss, or some sort of .NET service. And inside of there's probably many service components in there. It might be they might be hosting different applications, different WAR files. It might be a web service, might be a web request service running in there. And they may all interact with each other, but you don't really see that. You just see that transactions come out of the web server, they go inside of the JVM, it does things, they interact with each other, and maybe then make external calls out to databases or other services. Well, what we focused on with Dynatrace was being able to automatically detect those different services. So even though it's all running within the same JVM here, but being able to see if you have different web services running there and if they're interacting with each other. And that's actually what you're seeing here is we actually, in one of our monolithic JVMs here, we had a booking service, a journey service, and then a configuration service, a whole bunch of other things inside of there. They're all interacting. When somebody actually goes to a website and actually were to interact, they're hitting all of these different services. And what we also wanted to know was how tightly coupled these different components are. Because you remember, if you're going to decide to break them out into different services, you need to make sure that how tightly coupled things are. Because remember, these are now basically in-memory calls. They might be interacting as different service endpoints, but they're talking within the same machine. They're on the same JVM. They're essentially making in-memory type calls. They're very fast. But if you break that apart and put them on different machines out in the cloud where you don't even maybe not know where they're running, you're going to be introducing latency. So these are things you want to think about and whether you want to actually break things apart in certain ways, because if they're tightly coupled, like in our example here, where almost every time somebody calls our journey service, the check destination service will always get called. Well, if you create latency there, you're already going to potentially slow down the transaction. So maybe that's something, or at least two components that you might not want to break up, or you want to break it up a little bit differently. So kind of just exploring how you can do this is we looked at our service endpoints on our monolith there. So basically, a monolith consists typically of, you have service endpoints where data comes in, transactions come in. Then you have in and of itself, we looked at our service flow. And then it makes external calls to databases and queues or other services. So that's exactly how we kind of visualized it and built it into Dynatrace here, is actually showing you. So if we look at our customer front end, the service that we just looked at, basically in the summary view, what you can see is we've got our web server that communicates in, and then we have how many instances of that we have running at any point in time. So we know what machines it's running on, and we know what processes, specifically what JVMs this whole service is dependent upon. And finally, we know what this thing actually talks to outbound. We know it's dropping messages on 2 queues. We know what they are. We know that it's talking to a couple other services downstream. So we have just a dependency information in there. Now, the next thing is we want to determine what exactly are the service endpoints, meaning what are the actual requests that are coming in to this monolith, and then what ones are the most expensive. And by expensive, what we mean are, it tends to be the highest load, and which ones actually consume the most CPU cycles. So you might have ones that are used very often but don't use a lot of CPU resourcing, but then you might have the opposite, which is not the ideal effect, which are ones that are used very sparingly but actually maybe consume a lot of CPU. So those are things you want to think about, especially if you start moving into an environment where they're charging you for things like that. And maybe you want to think about re-architecting or taking a look as to how, why that consumes the way it does. But now you at least have an understanding of what the traffic patterns look like and what the resourcing gets consumed and which ones are the what type of requests are the most popular. So now what you could do is, once you get your endpoints, so we have all those drawn out, is you can see the full flow of this. So you can actually see, if we pick our little filter up top there where we pick our one service endpoint, and we say for that service endpoint there, when transactions come in, where does it go, and how often does it make those calls? And then give me some details about what the round trip time is between all of that, so that I can at least validate what it does today. And we can go a little bit deeper now into this, and we can actually say, endpoints can have a couple different types of requests. Maybe if it's an API type request, it could be doing gets, it could be doing posts, it could be doing different things when it does that. And the service flow could be different depending on what it's doing. So if it's getting data, that might be doing one thing, versus posting data, it might be sending data off to a couple other sources. So you want to be able to filter that type of view as well and get the same service flow, but then also be able to see what interactions it has. So if we kind of take a look back at what we just learned there by looking at the one instance of our monolith, is we know what our endpoints are and we know what the throughput is. So you now have an idea of what the traffic pattern coming in is. You know which requests are the most expensive. And then you know how it flows through the different components internally inside of your monolith app. And then finally, what calls it actually makes going outbound, what databases it's dependent upon, what external services, what message queues. So you have all of that just by looking at that, so kind of filling in the blanks here. So now the next question is, where do we want to determine these different entry points? So we know we've got different services in there. Maybe we want to experiment and think about which component in there could be a good entry point to break apart into its own little service. And if we did so, how would that react to certain things? And so within Dynatrace, you can actually do this. You can actually take basically a code sample here and actually use like CPU sampling to actually determine what is running live on the CPU, what code of yours is running live on the CPU at that time. So what we see here is we search for our own package. So our web app in this case is called Easy Travel, and so we just do a search for the Easy Travel package, and then we can find, okay, there's an entry point there called perform a booking. So now we can say, well, all right, that could be an interesting service of performing a booking, and that could be. Did I lose my audio? Oh, I'm back. So that could be something that we want to break apart into its own little microservice. And so to do this, so maybe you want to visualize how this is done. You don't want to refactor your code and just determine or prove whether that works or not. You want to actually be able to see how that would react today. And all you need to do in Dynatrace, we built this in to be able to define a custom service or be able to define your own service, is quite simply put in the name of the class, select the method, or even you can actually do a search and it will pull all of that data back and do a live search for you and say, give me an entry point. Start a service right there, and that's an entry point to my service. And once you do that, you now can have your kind of full view now, where you can see all of these different service components here inside of one view. And if we take a look at how that looks kind of in Dynatrace now, is you basically created an entry point, and that's kind of what it looks like live within Dynatrace. So basically what you've actually done at that point is you've virtually broken apart the monolith. And as I said, there's some tightly coupled services in there. Oops, I think I skipped a slide there. So yeah, so as you can see, basically what happens is if you virtually break apart the monolith, you can, without changing code, without ever having to redeploy anything, without ever having to re-architect anything, you can actually see if you broke these components apart, what would it look like? What would your traffic patterns actually look like? So now going into the next area here is talking about the second piece, which is how do you validate different load scenarios? So how do you validate that your scalable architecture that you're going to be building is scaling the way you anticipate? Is it actually running properly at peak load? Are you spinning up or scaling too many service instances to actually handle the load? So maybe you're paying more than you need to, or vice versa. Is it not failing over properly as you expect it to? So using that whole Smartscape view we looked at earlier, you can look at that same service or any one of those services and see how many instances of it you actually have running at any point in time. And if anyone is failing, anyone is running into resourcing issues, you can see that in real time and actually be able to react to it and determine if your service is scaling properly. And going into where we talked a little bit about the AI and the baselining is you want to make sure that beforehand, before you make any changes or before you push out a new release, that the code is actually performing the same way. The services are responding the same way. They're not failing. And they're also consuming the same amount of resources. So if you look at the bottom box there where we look at basically the CPU that gets consumed per transaction on that service, you want to make sure that you're staying within bounds and not consuming more resources based on a release, even though your response time and failure might be fine. So this is what we actually like to call like the performance signature of a release, is basically looking at a couple different metrics like your response time to load ratios, failures, and CPU consumption. And it actually can tell you if if one release to the other actually is still performant. And what we can actually do with this, we could take this even one step further, and utilizing even some more of the Amazon services, is basically allow you to shift left and automating through your pipeline. Again, the whole goal of why we would want to move from the monolithic architecture to eventually getting into microservices and serverless type of architectures is to be able to push out code and release it a lot faster. And so with Dynatrace, what you can do is using, and this is an example that we're going to walk through here, using AWS Code Deploy and AWS Lambda and a couple other functions here. But let's just say we want to push a new build into staging here. So what we'll do is we'll say, OK, we're going to push a new build in. Now, what we're also going to do is we're going to have a Lambda function fire off and tell Dynatrace, hey, we're just pushing a new build out there. Here's some metadata about that build. Here's the build number associated with it. So Dynatrace will read that information. So we say, we're going to push this new Node.js service out there. Here's some build information with it. And now you're going to kick off your tests that you would normally run against the build. Well, what you can do is Dynatrace has that before and after concept built into it. So it's going to look for and detect regressions. And it can actually fail your build. So now you don't have to sit there being kind of like a manual performance tester and say, OK, this new build came out. Let me validate my data after we ran a test. You can actually have Dynatrace do that for you. And it can actually look at the data and actually determine, based on the performance signature, is the response time greater under these conditions. And you can have that comparison done compared to production data as well. So as long as Dynatrace is capturing production data, you can say, let's compare the two. So at that point, we'll determine whether that build was valid. And so you see between build 6 and build 7 that our performance is fine, or at least our performance signature approves. So now we say, OK, let's move that to production. And by the way, we can automatically trigger off a Lambda function and have that auto-approved and say, let's move on to the next stage of the pipeline, which is deploying this service out to production. So that's what we're going to do using Code Deploy. Do the same process. Tell Dynatrace again, but the production instance that we're deploying into production. And now we're going to say, OK, production looks good based on the data there, or it doesn't. Now, in this case here, there was a problem that manifested itself in production that for some reason we're not able to detect in a lower environment. And those things happen. There's environmental differences. So with that, Dynatrace, again, can detect a problem and say, this service now increased in a failure rate. It's now failing more than it used to. So as soon as that problem exists, you can have a Lambda function trigger off and have that directly send to a Lambda function to say, OK, tell Code Deploy to roll that back for me. And it can do that. And then basically you've resolved the issue. And all of that was done without having really any human intervention, which makes it a lot easier to push code through the pipeline process. And the other thing you can do now is when you make those changes in a lower environment, when you go through that process and you're running your load test, is validate using the service flow that you didn't make any recursive calls. So if this was your planned architecture to have it nice and clean from web server to web tier, and then you look at it and it looks like that, you might have a problem, or you might want to rethink what you did because maybe you added in a lot of N+1 type calls or recursive functions in there that maybe you just didn't even realize that just for a transaction, even though you thought it would go seamlessly through all those different services, well, it actually calls itself back and then goes back again. And these are the type of things that you can see in the service flow. So now the final phase that we talked through, which is being able to integrate with the cloud services. So going on to that where you want to actually have your different you're going to be using different services. In this case, maybe you're just using EC2, but maybe you're using like RDS or things like that. We actually made it in Dynatrace to be able to pull in a lot of that same metadata that you're using out in an Amazon-based environment here. So you can see there's different different tags coming in off these EC2 instances. So the things that you've already tagged and set up and have rules in place for your Amazon assets, we can actually pull in and actually be able to search for and find those same entities. So this is just a simple EC2 instance, but you see up top, we're automatically pulling in the different tags that are associated with that instance. And then you can do the same thing on the RDS database side. So you see on the right is we've got this Oracle database, which is moved out and running in RDS, and you can see what applications it talks to, and you can even see what services call this RDS database. And that's actually what you're seeing right here is that there's the RDS instance, and right at the lower left-hand corner, you can see which services are making calls to this database. And it's all in the same topology, even though, again, it's a database as a service model. And also with the integration, what we've done is built it so that we can pull in a lot of the other cloud resourcing, especially around AWS and what you see here. So being able to see how is your auto scaling if you're using, let's say, DynamoDB, being able to pull in data around and tie it together with how well your queries are performing, which ones you're actually running. And maybe if you're just moving to a containerized type of model, so maybe you're going to use ECS or newly launched EKS and be able to actually see what's going on with the different container services, we can actually do that as well and actually be able to monitor how well you're scaling out those containers by dynamically discovering when you spin up containers and what services they actually belong to. And the one thing, so now finally stitching it all together back from what George started with a lot of the Lambda functions, is when you introduce that into your environment, you want to have end-to-end visibility through the different services that you may add in. So that's what you actually see right here is a couple things. Is one, you're seeing if a Lambda function is invoked and what calls that makes outbound. But you can also see how long, or basically the duration, that your Lambda function actually runs. So it's kind of like a waterfall view of the different service calls. And obviously, it can help you optimize this because you don't want it's event-based. You don't want to be sitting there running or waiting for responses to come back. It's an event-based trigger. So you kind of want to make sure that you're optimizing it in a way that makes the most sense for how Lambda is actually designed to be used. And so if you want to look at a full service flow or an example of what one could look like when you're using a combination of having Lambda in there, having a Monolith in there, you can see that transactions may go through a Monolith app that still is out there that maybe you haven't converted yet, serverless pieces. You may have it out into a microservice tier, and then, of course, you're still going to have legacy and third-party, maybe calls back to the mainframe. We still can't, we're not getting rid of that necessarily in a lot of environments yet. So you can see basically the full flow of how that works, all the way up to the user, which is another thing that you can actually see is being able to validate the user's experience as they go through, and then the transaction flows through that entire area right there, and be able to monitor things like conversion rates and things like that, and how maybe deploying something that is a suboptimal deployment, how that could impact users coming to your site and things like that. And so the final thing that we'll talk about just for a minute here is all of that data is actually accessible as well via like chat ops or voice ops. So we actually have an Alexa skill out there. We have a couple chat bots out there as well where you can actually ask it questions. Basically, you can say, you can ask Alexa, was there any problems last night with my application stack? And basically, Alexa will respond using the Dynatrace skill to say, in reading the data that it has for your environment, if there were any problems, and if there were, how many people did it impact, how severe was the issue. So it gives you kind of a more flexibility, almost like you're live querying your data, but in a more answer-type fashion. So with that, we're going to stop now for Q&A. So if any of this actually interests you, if you're actually going on this type of journey and want to learn a little bit more about it, you can always stop by our booth. We're upstairs right in the expo center. Or you can go to dynatrace.com and actually get some more information, sign up for a trial. And so we have about 3 or 4 minutes now. We could actually stop for some questions. Actually, there you go.
Do you need to instrument the code, existing one, or do you have to deploy some agent to track all your calls?
So it's agent-based. You don't have to instrument your code. It's actually agent-based, and even with Lambda, we've actually made it so it's an event wrapper, so you don't actually have to instrument your code. But for anything else that you have a machine or PaaS type of environment, it's agent-based in that sense, but no changes necessarily to the code. Hang on.
So you mentioned that you worked with WebSphere before.
Yeah.
What was the journey like transitioning from WebSphere to something like microservices with Tomcat? I'm actually very interested in that. I'm trying to move my project towards it away.
Yeah. So we've done that with a couple of our customers along the way, and it's kind of what you would expect. It's a lot of looking at the different transactions and the different flows basically as they go through and the different service components, and then basically understanding what the dependencies between them are, and then looking at, okay, we want to move, this makes sense to break out into its own little service here, doing that, and then validating that kind of what you expect, the same dependency flow actually works, validating that everything goes through and validating that it's performant. So, I mean, I could talk to you a little bit more about some of it afterwards and some of the challenges you're facing, but yeah, it's something that a lot of people have gone through. Good?
Is this on? Okay, sorry. No, I was just tagging off that other question. So if we have a monolithic, just web application, so if it's not instrumenting the code to find all those points, I guess I don't know how that works.
So it is doing the instrumentation, but you don't have to change your code in order for it to happen, basically, is the idea.
Okay, yeah, because before you said you weren't doing
instrumentation. You as a person or me or anybody, nobody has to manually make any changes. It's just a matter of the agent on the machine will actually instrument the app when it starts up and then be able to actually trace things. Yeah.
Thank you.
And when you're building it, if you're moving to Lambda, you can also use a service called X-Ray, which can help you understand line-by-line execution of how your Lambda functions are functioning.
Thank you.
Yeah.
Okay, I'm new to the Lambda stuff. Are we really, I mean, there is one thing to be said, it's like, okay, serverless as a end user or a user of that function, you don't really need to care on how it gets deployed, or is it a server there or not, or the load it needs to take. It's taken away from you, and Amazon is getting it done for you. So that's one piece of it, as opposed to, no, this is a different kind of architecture, and actually behind the scene, there is no server.
Yeah, so let's be totally clear. Like, behind the scenes, there's definitely servers. All right, so AWS will run the servers and manage the infrastructure for you. With Lambda, you provide your business logic code, and then we execute it for you. So behind the scenes, it's not magic, right? There's always servers that exist. Yeah. It's just that you, as a customer, you don't have to manage that. Yep. One more question?
Yeah, sure. I don't know if I heard this right, but from what I heard, it looks like Dynatrace needs to have access to a database which is already deployed on the cloud. But what if it comes to a customer case where they do not want to move the database over to the cloud, but keep it on-prem, but connect via direct connect or some other feature?
Yeah, you can do that either way. It doesn't really matter. We can be hosted in the cloud, on premise. We're agnostic to that actually happening. So you can go through the same process wherever your app is deployed.
Okay, thank you.
Can you guys do one more?
Yeah, we can do one more.
I'm good. Yeah.
Is there consideration taken for how these things are generated when it comes to the 30-second timeout for API gateway or the 5-minute timeout for Lambdas?
So the question was, is there consideration for changing those numbers?
Yeah, well, what I'm saying is, like, let's say you have a process that might take 15 seconds, might take a minute and a half. So it's able to, is Dynatrace able to figure out, hey, this probably shouldn't be broken out into a Lambda or something that would go through API gateway?
I mean, that's one way you can look at it. It's not going to break it out for you or give you a recommendation itself. It's obviously looking at the data or giving you the data to be able to do that and then determine if that would actually make the most sense, giving whatever variables you want to use or whatever constraints you have to deal with. Should it go into a Lambda function? Maybe, maybe not, depending on how it actually works from a business logic standpoint.
Okay, but does it warn you about those? Does it warn you about those limitations when it's doing the benchmarking and the analysis of the code? Like if it's doing sample. I feel like I'm asking a really dumb question. You look really confused.
I didn't hear a piece of what you said there.
This will probably take a lot longer than we really have time for, so I'll try to track it down.
Does it deal with cold starts? How does it know when I'm breaking up all the services, right? And they're interacting. How will it let me know if I'm picking a service and it's going to do a cold start or a warm start? Will Dynatrace give me that information?
It'll tell you, obviously, if it started up slowly versus if it wasn't. You'd be able to compare and determine then if it was a cold or a hot start.
Yeah, with those, with cold starts and warm starts, we recommend either instrumenting your code with a third-party tool or deploying X-Ray. And it's really easy to do. You enable a single checkbox in your Lambda function, and X-Ray will give you all of that information. Cool. Anything else? Where's the mic? Thank you for coming.
Yeah, thanks, guys.
Bye.